Welcome everyone to our session, how RBI strengthens network security with AWS. My name is Florian Ettinger. Together I am accompanied by Roman Jokel.
Hi, I'm Roman Jokel, working as cloud architect in Raiffeisen, based in Vienna. Since 2019 I'm working with AWS, with Cloud Center of Excellence, which was established at that time. Meanwhile, I'm also participating in our Vienna AWS user group as a leader.
Thank you, Roman. So yeah, let's give you a quick overview on the topics we're going to cover today. So first, as you probably know, there's the well-architected framework, so the guide on how to build on AWS. And I want to kind of narrow this down today to really focus on well-architected network security. Then we want to focus on the infrastructure protection part of this, which then, of course, leads to the management of the network firewall and how RBI actually implemented a very cool process that lets the application owners self-manage kind of their firewall rules. And lastly, of course, and certainly not least, the monitoring and logging of this application to provide all the application owners with the necessary information they need to run their application. But before we start, let's do a bit of a deep dive on RBI. I'm not sure if everyone knows what RBI does. So RBI, Raiffeisen Bank International, is a bank that is headquartered in Austria and operates across Eastern Europe. But I think it's best to Roman to share what's...
So, Raiffeisen Bank International, in short RBI, is present in 15 European countries. In 2024, we got the Excellent Model Bank Award for cloud migration, with more than 40% applications migrated to AWS. We, as Cloud Center of Excellence, operate 7 AWS organizations with more than 1,000 accounts. And our goal is to deliver to the projects, to the internal customers, secured AWS environments, basically AWS accounts which are secured, network connected, and with that, the projects are building the applications on top of our application.
Thank you, Rowan. So, yeah, what we're going to focus on today is really we want to ensure that you can, and your application owners can build securely and comfortable. And for us, as AWS, security is really our top priority. I'm sure many of you heard about this day one culture from Amazon that's really about driving innovation. And security, for many people, is kind of in contrast to innovation. So many people see it as you either can be very innovative or be very secure. But it's often hard to combine those two. So in today's session, we want to kind of show you how RBI managed to build mechanisms that kind of combine those two, that lets you be innovative and move fast while still staying secure. And how to do this is kind of very well described already within the AWS well-architected framework. So for those who don't know it yet, the AWS well-architected framework kind of describes and distills down all the learnings that we, together with our customers, made while operating workloads in the cloud, and distilled it down to a framework that every customer can apply to kind of jump the initial hurdles to get started right off the bat with the best practices. And today, we want to focus on the security part, specifically the network security. And for the network security, for the, let's call it, well-architected network security, the most important parts are the infrastructure protection, which covers the topics of how you ensure that your data stays secure. This, of course, includes also the data in traffic and storing all your log data, for instance. Then, of course, you want to run your applications. So you will have generate a lot of network traffic. And you want to be able to analyze this traffic and detect certain problems, maybe attacks as well. So once you detect them, then the last part of being well architected is, of course, to be able to react for those incidents. So let's jump right into it. So when we talk about infrastructure protection, there are two parts to it, right? Those of you who already worked with AWS should be familiar with the shared responsibility model. And the shared responsibility model really means that AWS is responsible for the security of the cloud, and you, as the customer, are responsible for the security in the cloud. And of course, we provide you with a lot of services and features that lets you do this. But the great part about this is that by running your workloads on AWS, you kind of immediately inherit a lot of the built-in security mechanisms. So we really built AWS from the ground up to be the most flexible and most secure cloud computing environment in the world. And when we designed the system, we really made sure to cover also the most high demanding in terms of security workloads for the military, for global banks. And by using AWS, you get to use all those same mechanisms. So we really don't differentiate between any user. Everyone gets the same top level of security. And with this global scale, we also allow you to scale up and down your operations, which allow you, for instance, to easily fight or more easily fight against DDoS attacks. And all of this is, of course, built to the highest privacy, data, and security standards, which you can use then when you run on AWS to also accredit to your governance system. And the great thing here is that we provide you also with a lot of features to automate a lot of those processes. So this is really when you then can reduce your manual burden and cover a lot of the reoccurring tasks or even let them be managed by us. And lastly, we have the largest ecosystem of security partners and solutions available. This means that if you currently are running your normal data center on-prem and you have an established firewall, maybe with one of your partners, with third-party vendors, you can easily also continue your collaboration with them when running on AWS. So now let's look at the different ways on how you can actually secure this data in the cloud. And for this, there's a multitude of services available for you. And what you end up then in the end is this AWS layered security. And I want to now give you a quick overview of what's available to you kind of on the different levels. So first, of course, you have your VPC, which is basically a logical isolation for your computing resources, your own IP space, which you then can further subdivide into different subnets to separate your different compute instances. And to manage the traffic between them and the connections between them, you can make use of security groups and network access control lists. Those together allow you kind of to define what traffic is allowed and what traffic is blocked between your instances. So let's give you an example, for instance. Let's say you have some database instances and some application instances running. You, of course, want to make sure that only these application instances can access your databases. And you can set up the security group of your databases and the security group of your application instances in a way that only traffic from the application security group can be accessed or can access the security group of the database. But of course, staying within your VPC kind of has a limited functionality, right? So you will soon need to manage all the traffic that goes outside of the VPC, so reaching the VPC boundary. So there you want to implement then a firewall. And for this, you could either use the AWS network firewall, or you can integrate any third-party appliances together with a gateway load balancer that also reduces your burden. And for those two, we'll go into more detail later on and also see how RBI kind of did this process to be able to scale across all of their network banks. Lastly, you want to, of course, protect your applications. And with this, you can use either AWS Shield or AWS Web Application Firewall, for instance, to protect your applications against DDoS attacks or against common web exploits. And lastly, as I said it in the beginning, also a really important part, we provide you with tools like Amazon VPC Flow Logs to ensure you have the observability tools you need to really stay on top of all your applications running. But of course, all of those services together then end up in an architecture which will look something like this. And this is where I want to hand over to Roman to kind of explain how they use AWS to protect against very common DDoS attacks that happen to them very regularly on their on-premises setup.
So exactly, we would like to present you an example. Basically, we have a situation where one of our subsidiaries, Raiffeisen Bank in Romania, had a lot of DDoS attacks during the peak hours. And then on-prem DDoS protection was not able to filter out what is the user traffic and what is the DDoS traffic. And with that, they tried to build the application in AWS. So what they did, they use AWS CloudFront, they use AWS Shield Advanced, WAF, and place the application in AWS, protected by those functionalities, which is visible on the diagram. From that template, we created also a service catalog product for another projects that would like to present or create an internet-facing application, which they can simply in service catalog deep launch. This will create the needed endpoint, public subnets, and this gives us a functionality, the robust functionality that is also behaving very well on DDoS attacks. And in that case, we don't need to care about the DDoS attacks because AWS itself with the services is handling them.
Thank you. So, yeah, and a key element in all of this is, of course, your network firewall. And I hear, of course, from many customers that share that any change to the firewall necessary will require opening a ticket, going through a lengthy approval process. And all of this, of course, slows down the speed at which new applications can be made public to the customer, for instance. So let's go a few classic setups that we see with customers. So we have a few customers who really build everything on their own, use open source and custom built solution and manage everything by themselves. Then, as I said in the beginning, of course, a lot of customers running the cloud network use third-party appliances, just move them in the cloud. Some of them even route all their traffic back to their on-premise data center where they already have set up a functioning network firewall. And then lastly, of course, a lot of customers just use the cloud-native solutions like the AWS Network Firewall. And I want to kind of focus here, especially on the last part, on how the AWS Network Firewall allows you to build the centralized inspection to move you faster. So what challenges are we actually trying to solve? So, as said, normally running and configuring your network firewall requires a high operational burden when you're thinking about your on-premise setup. It's a lot of maintenance overhead. You need specialists who actually know what they're doing. And probably you have a mix of very different technologies that you need to stay on top of, or you need to have specialists who really know what's going on. Of course, there's also the topic regarding long-term contract commitment with third-party providers. And then, of course, you need to ensure that your firewall scales up and down depending on your actual demand. And you need to manage all of this, usually when you run on-premises by yourself. And this is where a service like the AWS Network Firewall comes in and really tries to alleviate all of those problems. So the AWS Network Firewall allows you to create a policy, block and filter traffic in and out of your VPC, and allows you to monitor the traffic going in and out. And of course, this applies to traffic either between the VPCs, this applies to traffic coming from a transit gateway, from somewhere else, from a direct connection, from your on-premises data center, or just from the normal internet gateway, so any public data. Additionally, the AWS Network Firewall also allows you to publish all the blocks either to Amazon S3, Kinesis, or Amazon CloudWatch, or of course, if you already have set up any security observability platform, allows you to publish those logs with an integrated partner solution. But of course, as I said in the beginning, you're not limited to this. So if you still want to work with a partner, but you still want to make it easier for yourself, then using a gateway load balancer can also reduce your overhead here a lot. So what a gateway load balancer does, it's like any other load balancer. It makes it easy for you to deploy all those virtual firewall appliances and automatically scales them up and down depending on your specific current needs. All the traffic that gets routed to and then from your gateway load balancer towards the correct destination then is kept as it is and encapsulated, so your actual applications owner will not see any changes to the traffic. So it's completely invisible and transparent to them. And this, of course, gives you a lot of benefits, right? Using a gateway load balancer, for instance, you can easily also swap out your virtual firewalls in the background if you decide you want to switch another one without having to redesign your entire network flow. The horizontal scaling of the appliances is kind of done for you. It's set up in a fault-tolerant way to withstand any outages. So in the end, this all comes up, let's call it like a firewall as a service solution for you. So this is how you set it up, but how do you actually deploy them? And what options do you have there? So we have, roughly speaking, 3 different setups, right? So first, there's the ingress filtering, so any data or packets that are coming in. Then you have the egress filtering, so all the connections you build going outwards. And then you have all the traffic between VPCs. And for each of them, you may want to have a different architecture, but in general, you can group them kind of by a few different deployment models. And one deployment model that allows you really a lot of freedom is the distributed deployment model. So this really means every VPC and every, therefore, application owner can manage their own VPC, can manage their own rules, and really stay on top of their own application and own the model. Of course, through services like the AWS Network Firewall Manager, you can still ensure that on top you still have the top-down view and be in control of all of this. But of course, this requires a lot of manual management from all the different teams. So many customers also choose the complete contrarian deployment model of having this centralized inspection VPC deployment model. This as mentioned, basically means that all traffic generated from any VPC will be sent to a transit gateway, then to the inspection VPC, where it will hit one general firewall, and then is sent to the target. This can be then either, again, some other VPC or the internet. And of course, if there's traffic coming in, so the egress version also will first hit the firewall you have set up in your inspection VPC, and then it will be sent to the spoke VPC. These are kind of the 2 main options. But depending on your use case, you might want to actually mix and match them. And this is where I want to hand over to Roman, because RBI actually combined those 2 models to allow for great flexibility while still having one centralized inspection VPC. But Roman will tell you more about this.
Exactly. 2019, when we started our journey with AWS, there was no AWS Network Firewall in place, so we needed to fulfill the security requirements to have a firewall on edge of our networks. We needed to introduce a third-party firewall. In our case, it was Palo Alto. From the beginning, we connected it with VPNs towards transit gateway. Later on, we introduced also the gateway load balancer, which gives us the flexibility to auto-scale the firewall, to exchange the appliances during the life cycle, and that is visible on the right side of the picture. That's the north-south inspection VPC, where we also cumulate all of the outgoing traffic towards internet. With that, we have only a couple of public IP addresses that, for example, if you need to whitelist some incoming traffic on Office 365, we have only 3, and not having internet or NAT gateway in every AWS account. On the left side, we see the AWS network firewall in the east-west inspection VPC. It's the use case for it is whenever the traffic between the VPCs is flowing. So whenever spoke VPC1 would like to talk to spoke VPC2, it is routed on the transit gateway route table towards the inspection VPC, and based on the rule set, is allowed or not. If we look from the VPC level, we have only one transit gateway attachment with a default route pointing to the transit gateway, and this allows us to split on the transit gateway route table the traffic forwarded towards internet, towards different VPCs. On that slide, we see how the traffic towards internet is flowing. Why combined deployment? Because for when we would like to present an application towards internet, on the beginning we had one centralized VPC where we accumulated the public-facing applications. But if you would like to deploy in your account one part of application, the public-facing service would be in our account. This would mean that the development and deployment cycles is complicated and involves multiple teams. For that, with Gateway Load Balancer, we were able to introduce the traffic inspection in one VPC. So as mentioned, we created a service catalog product. Every account owner, when he needs to present the application towards internet, he can simply launch the product. It will create the needed internet gateway, the public subnet, the endpoint subnet. The internet gateway has an edge route table association, which means that whenever traffic comes from internet towards the public subnet, it will be forwarded to the gateway load balancer endpoint. Then the inspection is happening on the Palo Alto. Based on the rule, it will be returned to the load balancer. And with this, the developer teams or the DevOps guys simply can control the whole stack. They control the application when they deploy it. They control the load balancer. They can set up the AWS VAV, Shield Advanced, and everything which is in control or which they need to be responsible for.
Thank you. And yeah, we talked now about the different deployment options, but then once you deploy it, you can even go one step further. And we're going to shortly then talk about, or Roman will talk about how RBI built this self-management where all the application owners can create their own network fire rules, and through the automation that the C3, so the core team that Roman is part of, set up, still check that all the security and compliance standards are followed before they're actually published to the firewall.
So having one central firewall, this means that we need to have some kind of process where we deliver the input or the policies to it. What we did to enable every account owner manage his own firewall rules, we found we tried to make a process with GitHub, and every account owner or every account has his specific repository. Whenever a commit or pull request to the repository is done, there's a verification running on a GitHub action. When the rule is not compliant, it will be returned as a failure, and the guy who created the policy would need to rewrite the policy. When the policy is in correct way, for example, we don't overwrite. It checks also, for example, if the side range belongs to the specific VPC. If it's the case, then the rule is or the pull request will be allowed to do the review. So we have a second DevOps plus a security guy. After that, pull request was merged and approved by security. A GitHub action will deliver the logs the rule set to our S3. From there, we have basically two automations, but the process is similar. One for AWS Network Firewall, the second process is for the Palo Alto. We take it, we one more time verify the rule if it's valid. We pre-process checks. If we check if, for example, the Palo Alto is currently not under commit, so it would block the automation. Or, for example, we have a kill switch functionality in case we would like to do a deployment, or, for example, change the firewalls behind the gateway load balancer. We put the kill switch, and no new rule will be applied. And whenever everything is fine, we translate the JSON to Suricata in case of AWS Network Firewall, and towards Palo Alto XML API in case of Palo Alto.
Thank you. So now kind of that we set up the infrastructure protection and allowed our teams to actually manage their firewalls, the last step in our journey to a well-architected network security is to set up the monitoring and logging. And I've kind of created here like a rough diagram of a network monitoring example, which probably each and every one of you has created already or currently running in some way in their form. So just to quickly go through it, so basically the AWS network firewall already collects the metrics and the logs. Those are then further analyzed or used for the monitoring, for which you can, for instance, use Amazon CloudWatch dashboards to really dive deep on the data to ensure that your network security teams really stay on top and stay aware of everything that is going on, while giving still the freedom for all your application teams to make the changes necessary as they see fit. Of course, as part of the monitoring, you can also then set up alarms, do an anomaly detection, or some simple metrics math. And once one of those alarms is triggered, or once through your monitoring you detect there is actually a problem, you of course want to act. And you could, of course, also just create some time-based rules or trigger those actions based on some other events. But through the acting part with, for instance, the Amazon EC2 auto-scaling, you can immediately react if you see an increase in network traffic. Or with Amazon SNS, you can even create more advanced automations that help you really solve problems and detect any problems and solve them directly without you having to manually dive deep and even wake someone up. So for instance, I have customers who have built a pipeline like that no longer need an operations team because they have set up everything in a very automated way. And this helps the network team, of course, to stay on top. What is really important also, when you give the application owners the chance to manage their own network firewalls, that you also need to provide them with the information to actually, change the rules as they see fit and provide them with the right information to actually, manage their own firewall. And to do this while still centrally collecting, RBI built a very cool solution that lets the application owners see their own logs without having access to all the other data that they should not have access to.
Yeah, so having the automation for creating the firewall rules is important, but having also the visibility, why, for example, a traffic was allowed, why it was blocked, is also important. And for that, we catch the flow, basically the logs from the Palo Alto. With FluentBit, we send the logs to Kinesis data stream. From there, we forward it to Firehose, and on Firehose, we execute a Lambda. The Lambda is looking, it has a mapping which account has which IP addresses, and with that, we segregate the traffic on a central S3 with the path for every account. When we have the logs now segregated on the S3, with Amazon Glue, we create the partitioning and tables. And from the user perspective, in every spoke or user account, we have a special role. And that role has only the permission to query with Athena that portion of logs which belongs to the account owner. We have this also on a network unique level, where we have a couple of accounts bundled together. And this gives the possibility to check what traffic was blocked. So we as CCO are not involved in every troubleshooting session because the developer can have a look on, check on his own why the traffic was blocked. And in the end, it improves the time to deliver or to improve the rule set.
Thank you. So yeah, this is kind of the rough overview on how you can build really the well-architected network security. So since we are coming to the kind of end of the session, I first, of course, want to use the time to provide you also with some more resources if you want to follow up. So if this topic really interests you and want to dive deeper, there's the AWS white paper on building a scalable and secure multi-VPC AWS architecture. On the other hand, if you want to learn more about RBI and story, there are two case studies and customer stories which are linked here. And of course, Roman and I will also be later on somewhere next to the stage if you want to come to us and ask some follow-up questions. But since Roman already mentioned that kind of RBI started a cloud journey in 2019, and in the beginning, many features that we presented today were not even available. for us, it's really important to always hear the feedback from our customers, where we then, to make the life easier, build new features, new services for our customers. So I want to use the time also to ask Roman kind of what the next projects are that RBI is kind of planning to further enhance the freedom that they can give all of their different network banks while still managing it centrally with their Center of Excellence from Vienna.
Yeah, that's a good question. So basically we are working on, so what we saw was an hub and spoke network infrastructure. But if you have a bank, like we have our colleagues from Ukraine, that they needed to migrate in a very fast way to AWS, we give them their own networking account and we built a framework called Hub Up Spoke, where they can manage their own network with their own AWS network firewall. And they can, with service catalog products, simple account, migrate VPCs connected to the central hub to their own hub. So that's the next step. And basically, we are trying to put as much as we can towards service catalog. So VPC self-management is something that we are currently working on. Later on, maybe giving more visibility on our troubleshooting functionalities. We have a lot of questions. Why application placed in account A cannot talk with application in account B? This consumes our time, so maybe we will provide a functionality which gives simple check of the whole path between the two source and destinations, if this is working or not. Yeah.
Thank you. Yes, and with that being said, also I want to say a thank you for working together over the last few years. It's been really a pleasure, and yeah, I hope also everyone here kind of learned something today. Feel free, please, to connect with us after the session. We'll be somewhere in this area. Yeah, thank you for being here today, and see you around, hopefully next summit as well.
Thank you.
Will you guys go?